Hi everyone, welcome to the first part of our Minesweeper automation tutorial. Today we're going to define the working region of the game and extract the values from each cell on the Minesweeper board. For this project, we will be using Sikuli, a tool that allows us to automate tasks by using image recognition, simulating the keyboard and the mouse. Sikuli works by finding patterns on the screen, in this case, the Minesweeper cells, and interacting with them, making it perfect for automating games or any visual tasks. We'll be identifying what each cell contains, whether it's a number, a bomb, or just an empty space. Let's dive in and get started. First of all, let's define an enumeration to represent the different statuses that a cell can have. This will make our code image clearer and easier to understand. We're going to create a class called cellStatus, where we will define 5 different status for the cell. A noun for when we haven't checked what is there in the cell. Not visited for the green cells that have not been clicked. Empty for the cells that we have seen that there's no number and no bomb. Clicked for those cells that we have clicked but we don't know yet what is there. And bomb for those that we have seen or calculated that there has to be a bomb. We are using negative numbers for the enumerations because we saved the positive numbers for when we find numbers in the cells. We will define a region of the screen where our image searches will be done. To do that, we just click over the region button and we draw a rectangle by drag and dropping over the game board. Then we have to create a matrix to represent the Minesweeper board. This matrix will store the status of each cell and we will fill it as we process the board. For now, we will initialize it with cell status not visited for every cell. In order to define the rows and the calls, we just have to go to our Minesweeper and count it. So in this case, we have 18 columns and 14 rows. We need to calculate the height of each row and the width of each column based on the dimensions of the board region. This will help us to determine where the cell is located within the game region. It's important to be sure that the result of the division is a float, because over integers we would lose pixels. That's why we are casting the rows and the columns to float. Now that we know everything that we need from the board, we'll write a function called getCellNumber. This function will check each cell on the Minesweeper board and return the correct status based on the patterns that we find. For instance, if we detect a bomb, we'll return cell status bomb. If it's an empty cell, we'll return cell status empty, and so on. Now, by clicking on Take a Screenshot, we will be able to pick the images that we want to find in the defined cell. We would normally ask to Sikuli if the image exists inside the region, but we know that this isn't a slow solution and that's much more interesting to use findAll.hasNext, which will give us the expected results, but with a much better performance. Then we just have to repeat the same process for the different status and numbers. If we click over an image, we can check that every pattern is matching. Otherwise, we can adjust its similarity. In order to know what is containing every cell, we will iterate the whole matrix that we have defined. For each cell, we will define a region by calculating its position, height, and width. Once we have the cell region, we will ask the function that we have already created for the number or a status inside the cell. Then, when all the cells are saved, we can print the matrix to see how it ended. So just click on Run to run the project. After Sikuli checks all the cells, it will print the result of what it has found. Notice that on different resolution or games, it might be needed to adjust the image pattern similarity. And that's all. Hope you liked it, and see you in the next part of the tutorial. And remember that Softmacros offers automation services for almost any repetitive computer task. Contact us at softmacros@softmacros.com.